Good afternoon, ladies and gentlemen. Welcome to your video lesson for lesson 4.1. We're starting a new module here. This is about identifying graphs and sequences. So without any further ado, let's get into it. So in the warm-up, it says find the next three numbers in the sequence. So again, this module is all about sequences, so we're getting a little bit of practice here. First thing you have to do is figure out what the pattern is in order to get, any of this right. So how am I going from 14 to 9, and how am I going from 9 to 4, and then 4 to -1? Well, you have to take a common, or in this case, there is a common difference. I got ahead of myself there. We have to figure out what the difference is, or what's trying to make that work, right? So what I've noticed is that it's going down by the same amount each time. And so if I take 14 and I subtract 5, then I get 9. If I take 9 and subtract 5, I get 4. 4 subtract 5, I get 1. And so that's what I'm doing. So I have to continue to subtract 5, right? So -1 minus 5 is -6. -6 minus 5 is then -11. -11 minus 5 is then -16. And that is my sequence. That's the next three. Now, this one's not the same. There's a whole lot else going on, right? I'm not adding because it's going down, and then I'm not subtracting because it's going back up. And if I notice, the difference between the two numbers isn't even consistent, right? The difference here is 8. The difference here is much larger than that. And the difference between 18 and 54 is much larger than the previous difference. So what's going on? So when I think about this, I'm wondering, like, first of all, how in the world am I able to get this positive, negative happening, right? And so what's happening here is that I'm multiplying. I have to be multiplying by a negative. That's the only way that I can get that positive negative to happen. So the question then is, what am I multiplying by? So how do I get from 2 to 6? Well, I would multiply by -3. How do I get from -6 to positive 18? Well, that's also -3. And so what the problem is, well, what I'm doing is multiplying by -3 each time, right? So if I continue multiplying by -3, -54 times 3 is now a positive 162. Then a positive 162 times -3 is a -468. And then -468 times a -3 is 1458, 1,458. All right, so kind of an intro to our sequences here. All right, another thing we're going to be doing quite a bit still is evaluating. This is something we've done way back earlier in the year, and so it shouldn't be too difficult to do. All we're doing is taking the values for A and B, substituting them into our expression. So let's evaluate each expression for the given values of the variables. Variables are A and B. A is 3, B is -2. So here I am substituting 3 in for A and then -2 in for B. And then I just got to follow order of operations because it's not an equation I need to solve. Multiplication comes before subtraction. So I'm going to do 9 times 3 first to get 27. And then I will do -4 times -2 next to get 8. And then I'll add the two together finally to get 35. So that is that expression. Next one here, x squared plus y, and then now x is -3 and y is 4. So I'm going to substitute first. So -3 goes in for x. And it's in parentheses, right? We talked a ton about how when we square something, if it's in parentheses, it becomes positive, and if it's not in parentheses, then it becomes negative, right? So just kind of rehash that one more time. All right, so if I have -3 squared versus parentheses -3 squared, remember this one means literally whatever's in parentheses multiplied by itself twice, which gives me +9. This one says to separate it as -1 times 3 squared, okay? Which means I take 3 and square it to get 9, but then I attach the -1. -1 times 9 is -9. All right, so anyhow, that was something we learned a while ago. Let's redo that. And then continue on. So -3 squared is +9, plus 4 is 13. Okay, so our lesson today, again, identifying and graphing sequences. So what's a sequence? A sequence is a list of numbers in a specific order. Now, that specific order is usually defined by a function that we use. Now, we're going to have a different word for function in the next slide or two. but it's literally going to be a function, right? And a term is an element in the sequence, right? So let's just give you a basic sequence here. So if I have the sequence, and let's say it's like, 2, 4, 6, 8, right? I'm just counting by twos. What we're going to end up having is we're going to start all of our terms with like the 0th term, and then the first term, and then the second term, and then the third term, and so forth, okay? So we're going to have these things called term numbers, okay, term number. And then we're going to have values, term values, that are associated with that, okay? The term number for term 0 is 2, term number 2 is 6, term number 3 is 8, and so forth, right? And a term in general is an element in that particular sequence. So let's go look at this example here. It says a go-kart track charges $5 for a license and $2 for each lap. If you list the charges for lap 1, lap 2, lap 3, and so on, in order, it forms a sequence. Right? And the sequence is 7, 9, 11, and 13. Or 1 lap, 2 lap, 3 lap, right? We could also talk about like, well, what would happen at lap 0, right? And this would be the first lap, this would be the second lap, this would be the third lap. And you might be thinking to yourself, like, well, why would we even talk about lap 0? It's like you didn't do anything. Well, it's possible, right? It could be possible for me to say that, you know, I went on a day where the track is closed, but I still got my license somehow, right? So I paid my $5, right? That would be the 0th term. And so that's all I did. I had 0 laps and I paid $5. And that's literally what happens until you drive a lap, right? This would be the sequence. And this would be the 0th term, first term. We can say the 4th term would be 13, but it also like represents like for 4 laps, it costs $13, right? And actually, that's what this says here. It says write a function notation. It says what does f of 4 mean? So we're going to talk about that. So a function, remember, has that f of x in it, right? And our function would be this. It would be 2n plus 5, where n is the number of laps, right? So the function of the amount of laps, you substitute the amount of laps into the function. We multiply all the laps by 2 because it's $2 per lap. And we add $5 to that because we pay $5 no matter what. Okay. And then f of 14, I'm sorry, f of 4 equals 13. That would mean, and I can just kind of, let me get rid of this. Page, come on now. F of 4 equals 13. That means that 13 laps costs 4 laps cost $13. Okay, 4 laps cost $13. That's what f of 4 equals 13 means. I could also say like, f of 2 is equal to $7 or $9, right? F of 2 is 9. That means that we have those amount of that cost for those amount of laps. All right, moving right along here. Now, I said that we're going to rename, like earlier on, let me just go back to this for a second. We said that a sequence is defined by a function, right? And I said we're going to have like a different word for this function, right? When we talk about sequences, a lot of times we just kind of switch some language around about what we already know, right? And so that's what kind of is happening here. An explicit rule, I want you to just think of this as a function, okay? So an explicit rule is really a function. And the good news is that, well, we know how to handle functions, right? We substitute values into the function, we get answers out, and we get our y values. Well, instead of y values, what we're going to say is that we're getting numbers for the sequence, okay? So we're substituting in, we're going to find the 0th value, the 0th term, and we're going to get our 0th term value, okay? So that's just kind of like flipping the script here. So let me just read what this says, and I want you to then really understand that it's explicit rule is really a function. So an explicit rule is a rule that defines the nth term as a function of n for any whole number n greater than 0. Okay, this really should say greater than or equal to. It can be used to find any specific term in a sequence without finding the previous one, which means like I can find f of 25 because I can substitute 25 into that function or explicit rule, okay, and get my value. So explicit rule, this sounds really complicated. It's just a function that we're using, right? Except all of our functions are going to start at 0, right? We're going to always start at 0 with this, okay? And that's going to make more sense later on when we do some graphing stuff. So it says write the first 4 terms of the sequence defined by the explicit rule. Remember, it's just a function. So here's my explicit rule function, right? And what am I doing? Well, I'm substituting in my first 4 values. Really, there's 5 here because I want to start at 0. So I have 0, 1, 2, 3, and 4 that I'm substituting in. So when I substitute in 0, right, I'm literally putting 0 in for n. I'm taking 0 squared, and then I'm subtracting 5 to get -5. And then if I substitute in 1 squared is 1, subtracting 5, and I get -4. 2 squared is 4, subtract 5, and I get -1. 3 squared is 9, subtract 5, and I get 4. 4 squared is 16, subtract 5, and I get 9. Not 9, 11. Sorry, 11. All right, so that would be the first 4 terms defined by this, right? And sometimes we'd see it just like -4, or sorry, -5, -4, -1, 4, and 11, right? And this would be the 0th term. This would be the first, second, and so forth, okay? All right, next one. Find the first 4 terms in the sequence defined by this explicit rule. Remember, function, right? So 0 goes in. 4 times 0 is 0. -3 is -3. Get rid of my picture here. And kind of undo that because I don't want it to go in there. 1 times 4 is 4. -3 is 1. 2 times 4 is 8. -3 is 5. And it happened again. Get out of there. 3 times 4 is 12. -3 is 9. And then 4 times 4 is 16. -3 is 13. Okay? Now, you're probably saying to yourself, like, well, this is no different than what we were doing before. You're right. It's not any different. We're just changing the terminology, right? We are now calling this a sequence defined by an explicit rule instead. So we said that an explicit rule can be used to find any term value without finding the previous one, meaning like I can find the 51st rule, the 51st term value without knowing any of the previous ones. A lot of times when we do a sequence, let's say like, if I have 2 and then 8 and then 14, right? And I want to go ahead and find the 80th term. Well, I might have to do this 80 times or 79 times then to find the 80th because I recognize like, oh, I'm adding 6 each time, right? But the explicit rule function, remember, allows me to substitute 51 in for n and then figure out what the 51st term is, okay? So I want to know what is the term value. What is the term value? Right? If I do that, I'm literally taking 51 and substituting in for n. So I could say that f of, and then I'm going to say 51, right? Function evaluated at 51, or in this case, it's the 51st term. Okay, the 51st term is equal to 51 squared minus 5. Okay, now I don't know what 51 squared is off the top of my head, so I'm going to grab my handy dandy calculator. 51 times 51 is 2,601. And if I subtract 5 minus 5, I get 2,596. So the 51st term is 2,596. Okay, there are 50 terms that come before it, but the 51st is 2,596. Now, number 4 is the same idea. I want to find the 101st term, okay? Now, all I'm doing is substituting that 101 in for n. So here it goes. F of 101, 51st term, or the function evaluated at 101, Same idea, right? 4 times 101 minus 3. 4 times 101 is 404. Subtract 3 from that, I get 401. So the 101st term is 401. There are 400 terms that come before that, but the 401st term is, I'm sorry, there's 100 terms that come before that. 101st term is 401. This is the term value, right? Term value. This is the term number. Okay, good deal. Now, what if I want to work backwards, right? Well, what if I know the term value, but I don't know where it appears in the sequence, right? I don't know the term number, right? What if that happens? Well, all that means is that I have to solve an equation, right? So let's read through this problem. It says the number 620 is a term of the sequence defined by this explicit rule function. Which term in the sequence is it? So what we're looking for is what is the term number, right? We don't know what that is. So here's how we do it. We take the 620, but instead of substituting in for n, it goes in for f of n. And it's not like in parentheses like we were doing before. It's literally wiping out all of f of n, and that 620 goes in that place. I don't like how that turned out. So 620 is then equal to n squared minus 5. And now I just have to solve this for n. And when I solve it for n, I will know where this number appears in the sequence. I will find the term number. So what's happening to n? I'm squaring it, and I'm subtracting 5. Last thing I said was subtract 5, so I'm going to undo that by adding 5 to both sides. There's my sides of the equation. So I have 625 is now equal to n squared. I will now square root both sides. And the square root of 625, I know off the top of my head because it's a perfect square, is 25. So 25 equals n. So what I can say is the 25th, well, let me start with the number that we're given. Let's say 620 is the 25th term in the sequence. Okay? So the next one is very much the same. The number 125 is a term value. I would like this to say value of the sequence defined by the function. Which term number in the sequence is it? Where does it appear? So 125, again, because I'm finding a term number, right? I want to find where it appears. 125 now goes in for this, for f of n. So 125 goes in for f of n, and then 125 is equal to the 4n minus 3. So what's happening? I'm multiplying by 4, and I'm subtracting 3. Last thing I said was subtract 3. So remember, we have to reverse our order of operations, do inverse diff. I'm going to add 3 to both sides. So I get 128. 128, then I have 4n is equal to 128. I will then undo the multiplication by dividing, and get rid of this. I end up with 32 is equal to n. So it means 125 is the 32nd term in the sequence. So as the sequence would be listed out, right, we'd have term number 30, don't know what that is. I have 31, don't know what that is, but I do know that the 32nd term is 125. All right. So after that, we really just have the recursive rule stuff, which we actually decided to kind of forget about. So we're not going to do the recursive rule stuff. I'm skipping that for this video. Okay. But we can do this example here about this museum. We'll be done. All right. So kind of in the way all over the place, but whatever. The museum charges $10 per person for admission and $2 for each of the 8 exhibits. So the museum has 8 exhibits, right? You walk in the door, they're like, $10, now give it to me, right? We're like, I didn't see any exhibits. They're like, I don't care, $10 just to walk in the door. That's the way they do it. But if you wanted to see an exhibit, there's 8 of them there, they charge you $2 per exhibit that you go see. So use a function and function notation to write an equation to represent the cost for attending an exhibit. So if it's a function and function notation, you know we got to start with an f of n. That is a horrible f. My goodness. F, that's somewhat better, of n is equal to, well, what am I charged no matter what? $10, right? And I'm adding to that cost $2 at a time, right? Not $8 at a time, $2 at a time per n exhibits that I go to, and n is equal to number of exhibits visited. Number of exhibits visited. All right. Let's make a table that shows the total cost of admission to admission plus 1, 2, 3 exhibits. So that is 1, 2, and 3, right? If I go to one exhibit, well, that means that 1 is going for n here, right? So 2 times 1 is 2. Add 10, I got 12. It's $12. 2 times, so 2 exhibits, 2 times 2 is 4, plus 10 is $14, and then 3 times 2 is 6, plus 10 is $16. That's what it costs individually for seeing those exhibits, right? If I see 3 total, then it's $16. What would f of 0 equal 10 represent? Well, we already kind of talked, like, that would mean that you walked in the door but saw no exhibits, right? So you were there, you were in the museum, but saw 0 exhibits. You're in the museum but saw 0 exhibits. Maybe you just had to use the bathroom. Who knows? Museum. My goodness. There's an M at the end of that. All right. Moving on here. It says graph the sequence. Well, by sequence, I have to have my axes labeled, right? So I should have, like, what's my independent variable? What's affecting, what is going into the function, right? So if I go back to the function, well, the independent variable is always here, right? Well, what is it? It's the number of exhibits. So let's put that on my x-axis. So number of exhibits, right? And then as I change the number of exhibits, what is affected? Well, it's cost, right? So I'm not gonna write this very well, but it's gonna be cost. You can put money spent or whatever. It's gonna be how much money you spend in the museum, right? So it's 8 exhibits I can potentially see. So I'm gonna go every other one and go 1, and then 2, 3, 4, 5, 6, 7, 8 exhibits. Okay. And at 8 exhibits, I want to figure out like how far this has to go. So I'm going to use the function. So f of 8 would be equal to 10 plus 2 times 8, right? Because I want to be able to fit everything on the graph. So I want to make sure my scale is appropriate to do so. So when I do that, 2 times 8 is 16, plus 10 more is 26. So I have to make sure this goes all the way up to 26. If I count this, it goes like 1, 2, it goes all the way up to 20, right? This is 20 long, I know that. Doing it with 18 here, so I should probably count by 2. So 2, I'm going to go 4, and I'm just doing this because I can't do it. I don't have enough space, right? So 2, 4, 6, 8, 10, 12, 14, 16, 16, 14, 16, 18, 20, 22, 24, 26, 28, and now I know I have enough that covered it, right? So at 0 exhibits, what would we have for a cost? Remember, we said it was $10. That would be right here. For 1 exhibit, that's $2 more. That's 12. For 2 exhibits, that's $2 more. So that's 14, which would be here. 3 would be 16. 4 would be 18. 5 would be 20. 6 would be 22. 7 would be 24. And 8, as we said, is 26. Now, I should not connect that because I cannot see 1.25 exhibits. And I should also title my entire graph. So this is costs for seeing exhibits. Missing some stuff there. My handwrite, sometimes my brain goes faster than my hand. Exhibits. There we go. All right. So what would be the total cost of seeing 8 exhibits? We already did that. We did that to find our exam. So we'd say that f of 8, not f of x, that's a habit. F of 8 is equal to $26, right? We already figured that out. So 8 exhibits would cost $26. All right. Then it says write a recursive rule to represent the situation. I talked about how we're not going to be doing the recursive rule, so don't worry about that. Okay, so this is everything that we covered in the Desmos, except for one more example that we did here. I hope that this was helpful for you. Again, you can always use these videos to supplement your understanding. All right, guys, I hope you're having a great day. Peace out.